Welcome back to Piping Engineers. So guys, in today's video we will be discussing about the heat exchanger interview questions. Many of our friends have requested previously also to give in questions that can be asked when giving the interview for heat exchangers. So guys, for better experience, please watch the video in 1.5x speed. I hope in today's video you will definitely learn something new and you will be able to crack your interviews that are upcoming. So let's begin our today's video. So the first question that we will be discussing in today, so it's a mixed video, guys. You will be seeing questions related to power plants, steel plants, so offshore oil and gas. So, but you should be prepared when you are going for an interview. An interviewer can definitely ask and test your knowledge, maybe outside the domain. So the first question here is, in a refinery, why are floating head heat exchangers preferred or preferred for heavy oil services? So the options are lower cost, better corrosion resistance, easier cleaning for high fouling fluids, or less pressure drop. So the correct answer here is easier cleaning for high fouling fluids. So guys, what happened in high heavy oil services, there are many foulings which can be which get sticks to the bundle or tubes. So that's why this type of heat exchangers are used. So floating head designs allow tube bundle removal, crucial for heavy oils, crudes and fouling services. Cleaning access is a major industry requirement. So the industry, the refineries are very congested, so the space requirements is very less. So because of that, we prefer these type of floating head heat exchangers. Next question is, for cooling water services in power plants, which material is commonly used for tubes to minimize corrosion? So the answer is copper alloy. So why copper alloy? Copper based alloys, maybe admittedly brass, Cu9 9 Ni 9010, are widely used in power plants. Why? Because they resist biofouling and have thermal conductivity. So that's why the other in preference to other materials, the copper alloy is used. Next is, in a shell and tube heat exchanger, why is the hot fluid often sent through the tube side when it is corrosive? So that the correct answer is tubes can be easily replaced. So industrial corrosive fluids, when they go out inside tubes, because tubes are cheaper and easier to replace than the shell. So it's not easy to replace this shell, but it's very easy to replace the tubes. That's why the hot fluid is often sent through the tubes. Moving on to the next slide. So in this slide, which flow arrangement gives the highest outlet temperature for the cold fluid in a gas heater? So the answer is counterflow. So counterflow, what counterflow does? Counterflow, maximizes temperature difference and is used in gas heaters, economizers, and diesel engine heat exchangers for better performance. If you know LMTD calculations, there this counterflow and parallel flow or cross flow sort of calculations are done, and from there also it is proven that counterflow gives the highest outlet temperature. Next is, why are fins added on gas side in heat exchanger used for HVAC systems? To increase the heat transfer area. So whenever the gas fins, not only for heat exchangers, whenever we talk about the fins, so the reason fins are given to the heat exchanger, or the cross section area or the heat transfer area can be increased. So gases have a low heat transfer coefficients, so fins multiply the surface area drastically and improve performance standard in HVAC coils. So this is the main role of fins. Wherever you see the fins, so the fins are given, so the heat transfer area can be increased. Next question is, which parameter is most important to check during heat exchanger vibration analysis? So the answer is support spacing or baffle spacing. So in a real plant design, vibration risk is driven by baffle spacing, since it controls the unsupported tube length. So baffles are provided so that the unsupported tube length can be supported. That's why it is a very important thing. Moving on to the next slide, guys. So what does high fouling factor in design imply? So how fouling factor means more maintenance frequency. So industries use fouling factors to account for dirt and scale formation. Higher fouling, more cleaning cycles, and large surface area during design, because in industry it's not always the case that the clean water or the clearest form of water or liquid is moved through the heat exchanges. So that's why the fouling factors are provided, and high fouling factor clearly specifies that the maintenance frequency will be more. So next question, Why are U-type heat exchangers used in high thermal expansion applications? So tubes can expand freely. So U-tubes, allow free thermal movement, preventing tube rupture in boilers, condensers, and petrochemical plants. So whenever whenever we provide YouTube type heat exchangers, so simply the purpose is tubes, because tubes can expand freely, and that's why in high thermal applications they are provided. Moving on to the last question of today's video. In a cooling tower heat exchangers, why is the approach temperature crucial? A very important question. So approach temperature is crucial because it defines required heat exchanger size. So to tell the heat exchanger size, the approach temperature becomes very crucial. So smaller approach means larger heat exchanger area equals to higher cost. This is very common sizing decision in process plants, so you should be aware of it whenever we are buying the heat exchanger. So we always discuss about this approach temperature. So guys, this was the top 9 questions we have tried to cover in today's video, and if you would love this video, we will definitely try to make more videos on this topic. So if you have liked the video and you have come till here, please follow us, subscribe to the channel, and put a like on the video. So thanks for watching the video.